Okay. Well, so we are in 3 points. So you made it through the easy ones? Okay. If you had trouble, I am glad to help you. Come see me. I don't have them today, but tomorrow, 1 to 3, I'm there. Wendy's there. I got an email that these are hard. I know they are. I spent hours with my teachers. You got to pursue the help. So if you had trouble, come see me. I mean, tomorrow, 1 to 3, just down the hall. Wendy's got all kinds of hours, but you got to get the help. Don't just let that stuff lie. If you didn't get it last night, and I didn't get it about half the time. I mean, that's not shameful or weird or strange, right? I mean, that's just normal. Math's hard. Math and science is weird and hard, and you got to get help. So go get the help you need. Tutor's available. I'm available. Somehow make sure, though, you really can do those problems from last night. That you really know how to do those. Get the help you need. Glad to help. All right. So this is 3.5, the hard ones. And that especially goes with this section. If today doesn't make a lot of sense, which I'm assuming it won't. I mean, really, math, science lectures worked for me less than half the time. I really understood what was going on. About more than half the time, the teacher was doing the Charlie Brown, the wah, 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 wah. I was like, I don't know what that guy or gal's doing. I'm just going to write this stuff down, think about it later, and go get help. And that's what I had to do. And it's hours and hours and hours. That's what it takes. So get the help you need. I'm hoping this will make partial sense today, but it is the hardest day. So expect some things to slip by you, but don't let them go forever. Get the help you need. That's the difference between the makers and the failures. All right, so let me start off. Before we throw the sines and cosines in there, let me remind you of the algebra rules first off. Do you know how to, we did one like this. This one's a little harder. This is kind of like number 2. I'll say it's like. Instead of x's, they're going to be sine x. Anyway, so how would you solve that for x first off? Do you remember? I think I put on the board Monday the x squared game plan, didn't I? What is that? When you have x squared with an equal sign, step 1 is? Get a 0. Yeah, that's got to be automatic for you. When you see x squared, you just think get a 0. Get a 0, and I should say a little more here. Get a 0 on the opposite side from x squared. Yeah. Get the 0 on the opposite side. So I'm going to take this 5x and jump it over here. Because the x squared's over here on the left, huh? So I'm going to get the 0 on the right. Is that making sense? Always get the 0 on the opposite side of x squared. So, okay, jump the 5x over and jump the minus 3 over. Thank you. So 2x squared minus 5x plus 3, 0. Step number 1.
Factor.
Good. Step number 2, factor. Now here's where this one's going to be harder. This is harder factoring than the one we did Monday. Then question number 1. This one's a little harder. The reason it's harder, I don't know what you remember from factoring. I know most people are pretty rusty. Is typical. When there's a number in the front, when there's a number in the front like that, that makes them harder. So, in other words, you can't just say multiply, add. Isn't that what I did on the one on Monday? I'm trying to remember. Didn't I just look here and go, okay, what multiplies to be 3 and adds to be 5? That doesn't work when there's a number in the front. Do you know that? Do you remember that from factoring? When you have a number in the front that's not 1, in other words, then you can't just say, hey, what multiplies and adds? It's not that simple. Instead, let me just write, when there's a number in the front, not 1, you must write 2 parentheses, or let me just, write a couple parentheses, and foil it out and keep checking. I mean, that's it. I don't have any magic. Well, yeah, I'm not going to give any magic formula because it wouldn't really be helpful in the long run. So, so that's what you got to do. You just got to guess. That's time consuming, but that's the process you really need to go through if you want to go to higher math anyway. If you want to go to pre-calc and calc, I remember my daughters, when I was helping them with pre-calc a couple years ago, they're just saying, Dad, I hate factoring, I hate factoring, I hate factoring. And my response was always, you got to learn to factor if you want to go up, if you want to go up the line. And one of them stopped right there. And she's like, I don't want to go up the line. I'm done, which is fine. She's doing other things. And the other one wanted to go, so she learned to factor. So, so if you want to move up to pre-calc calc, you've really got to get factoring down. And you can. It's just time. It's just practice. So you look at that and you go, okay, couple parentheses. Let me show you exactly what I mean. Couple parentheses. And we're going to have two things in each parenthesis, right? And it's just a matter of thinking out the FOIL backwards. We're just saying, all right, so front times front to make 2x squared. So what times what makes 2x squared? 2x and x. Not bad so far, right? And then look at the back two numbers. The last number times the last number to make the last number. Save the middle. We'll get to the middle. That's the hardest part. So what times what at the back? The back times the back to make 3. Well, 1 and 3. 1 and 3 clearly. So we'll just go, how about we just go 1 and 3? That's actually wrong. It actually needs to go the other order. I'm intentionally doing it wrong because I want to show you how you would go about figuring that out. So putting 1 and 3, it's actually the other way. Now the order matters. Why? Because somebody's with a 2x and somebody's with a plain x, and that's going to make a difference. Well, how do you know? You just got to FOIL it out. You just got to try it. You'll see it's not right. You go back and you make a change. You try it. You keep tinkering until it works. That's really it. So now what signs? I don't know. I'm just going to put plus for right now because there's just too much to worry about. I can do the signs later. So let me check if that's right. I've already told you it's not. But let's check it and see that it's not. So I'm going to take the 2x to both. You know what I mean by FOIL, right? If that is really the answer, then I should take the 2x to both and the 1 to both, first to both, second to both, and it should go back and become 2x squared minus 5x plus 3. It won't. So, and it's not just because of the signs. It's got deeper problems than that. It's the order. 2x squared, right? 2x times x, and then 2x times 3? 6x. Good, he's done. He went to both. First to both. Now it's the 1's turn. Your turn. Boom, boom. He goes to both. Plus 1x plus 3. See how that makes 7x in the middle? Yeah. Which is not minus 5x? Right? The front and the back are good, right? Front and the back, we already made those good. That's not the problem. The hard part's the middle. Getting the middle right. It's coming out 7x. That's not right. And that's more than a sign problem. It's not just, hey, it's the same number, it's just wrong sign. It's just wrong. So when it's wrong like that, just deeply wrong, what you do, what you try right away when it's not working is swapping the order on the back two. So I'm going to go, okay, the 1 and the 3 must be out of order. So I'm going to put the 3 here and the 1 there and try again. You tracking with me? I'll make both these positive. The signs aren't hard to fix later. I know they're not both positive. I'll fix that in a minute. Let's just get back to business here with checking. Mainly it's the order you got to get straight, and then the signs are easy to fix after that. Here we go. Try it again. First to both. 2x squared plus 2x. Second to both. Plus 3x plus 1. Now see the middle? 5x. That's the wrong sign. Whoops, that's not 1 at the back. Why did I do 1? Going too quick. Sorry, am I messing you up? Let me slow down there. Is everybody tracking with me? See what happened? Right, I took the first, I took the 2x, and I went to both. That's how I got this and this, right? 2x times x, 2x squared, 2x times 1, 2x. And then he was done, and then I did the 3 to both. And I got the 3x and the 3, right? 3x times 1, 3 times x, and 3 times 1. All right, and now the middle two make 5x, which is right, except for the sign. That's what I want. That means I have the order right. I just got to make the signs right now. Now, how do you make that minus 5x in the middle? Do I make them both negative, one negative? What's it going to do? Yeah, right, exactly. Both are negative, bless you, because you want this guy to be positive 3. 2 negatives will multiply to be positive 3 at the back. They'll make both these guys negative, which will make negative 5x. It's good. It's working. That's the FOIL that works. Everybody see that? So that's what you got to do. You just got to guess around until it works, which I probably shouldn't erase it all. Anyway, so there it is. So I'm going to go back now, and I know there's another step here. You know, next step, each one gets their own 0 and you solve because of two things multiplied to be 0. But let's go back and do it for the trig stuff now. Now that we know how to factor, let's go back. All right, so here's the actual question. Same thing, but it's signs instead of just regular x. So here we go. What's the game plan when you have sine squared or cosine squared or any trig? Let me just say trig squared. Any trig to the second power. Well, I might as well just write x squared. Same game plan. Whenever you have x squared with an equal sign, step 1 is get a 0. Same thing, so I'm going to jump these two guys over. It's the same thing. So I'll get 2 sine squared minus 5 sine plus 3 equals 0. Step 2, factor like we just learned. So it's going to be 2 parentheses. 2 parentheses equals 0. So what's going to go? There's going to be a front and a back for each parenthesis. So what's going to be in the front of the two fronts? What two things can multiply to be 2 sine squared? Yeah, 2 sine x and regular sine x. Huh? Is that making sense? 2 sine times regular sine is 2 sine squared, isn't it? Just like 2x times x is 2x squared. It's exactly the same, isn't it? And then back times back to be 3. 1 and 3. But now we know the order, don't we? Because we just did it right here. The 3's got to be with the 2. So the 3's got to go there and the 1's got to go there. And the signs have to both be negative. So you could check it. We already did. I'm not going to do it again. That's correct. That's the right factoring. We good? And now, step 3, each one gets their own 0 and solve. That's because if two things times to be 0, if I said, hey, I'm thinking of two numbers, they multiply to be 0, they times to be 0. Either one could be 0 to make them times to be 0, right? The first one could be 0. The first parenthesis could be 0. Or the second parenthesis could be 0. Either parenthesis could be 0, right? Because if the first one's 0, 0 times anything would be 0. If the second one's 0, anything times 0 is 0. So now we just solve both of those. So how do I solve this one over here? Let's just jump the 3 over. 2 sine of x is 3. Good. And then what do we do next? Divide by 2. Boom. Sine of x is 3/2. Okay, then let's do the other side. Jump the 1 over. Sine of x is 1. Okay, so now we go to the unit circle and we grab those answers. We good? So let's do this. Let's do the right side first. So we'll go there to find 1. So let me grab the unit circle. Find it back here. There it is. All right. So where is the sine of x equal to 1? Doing the right side first. Remember, it's cosine sine, cosine sine, cosine sine, there it is. See it right there? Cosine sine. Sine is 1 at pi over 2. And that's the only place. This is one of the rare ones where we only have one answer. You know, it's 99% of the time we get 2 answers every time we go to the unit circle, huh? There's only one spot where sine is 1, straight up. The height is 1, huh? So pi over 2. So this means x is pi over 2 only. Now, what about the other side? Sine is 3/2. Where's 3/2? That's not one of our numbers, is it? Our numbers are what? They're 0 and 1 and negative 1. And, and then, what is it? 1/2 root 2 over 2 and root 3 over 2. Right? Small, medium, large, and then 0 and 1, basically. That's it. That's the only things. Are you clear? Because today something, at number 12, 13, 14, they're going to do something very different as well. So let's make sure this is super clear in our mind. The only numbers we can ever get off the unit circle is 0 and 1, or the small, medium, large, 1, 2, and 3, the square root of 1, 2, 3 over 2. That's it. So we're not going to find 3/2 here. That's not going to be here. Square root of 3 over 2. If there was a root on the top, that would be here. But not plain 3 over 2. That's not here. So what's up with this? Well, do you know when the value is not there, what you should do is use your calculator and do inverse sine. That's going to become especially important on, I think it's number 12 today. So it's not, so let me write not on the unit circle. So it's not one of our memorized or on the unit circle values. So we do sine inverse. You know what I mean? I'm trying to find the x, and it's gonna, what are you getting? You should get error or no answer or something like that. Right, because there's no answer. The only answer is pi over 2. Now, why is there no answer? Let me give you a reason why. But everybody able to get that in their calculator first off? Right, so you hit sine inverse. Right, because we want to know the angle whose sine is the answer 3/2. Remember inverse trig functions? Remember when we did inverse trig? We want to, 3/2 is the answer. You want to know the angle. Anyway, what is 3/2? Let me show you real quick why that's the case. Why is sine x equals 3/2 no answer? Do you know what 3/2 is? It's 1.5, right? Remember the sine graph? How high does he go? How low does he go? Does he ever go up to 1.5? No, that's impossible. They just said, find the angle, these are angles down here, right, on the x-axis. Find the angle whose sine will be 1.5. No, sine is never bigger than 1. Never, unless you put an amplitude in front. If you put a 7 sine or something like that, remember, then that made it go higher and lower. But there's no number in front of this. I got rid of that too, right? This is just plain sine. Just a 1 in front, huh? The biggest that's ever going to be is 1, and lowest it's going to be is -1. Never going to be 1.5. That's impossible. There's no angle whose regular sine with nothing but a 1 in front comes out 1.5. Not possible, right? We know that from the graphs. It's the highest sine goes is 1, unless you alter his amplitude, and this is a 1 amplitude. So there's no answers out of that side. Nothing, no answer. And so the only answer is pi over 2. We good with that? Questions? All right, right here we have a sine squared and a regular sine. So that is when you got to do this whole get a zero factor thing. Okay, but on this one, we only have cosine squared. No cosine to the first power, huh? So these are easier. This is good news. Well, so this one has no cosine first. When you have only x squared, no x to the first, it's easier. You just get the x squared alone. You don't need to get a zero. You don't need to factor. Then you put a root on one side and a plus or minus root on the other. These are quicker when you have only x squared and no x to the first. So that'll be nice. So let's do that. So what's my first step then? I'm supposed to get the squared thing alone. So that would be the cosine squared, right? Got to get him alone. So what do I do to get him alone? Add the 12 or just jump the 12, either way. Move it over there. So we get 16. Cosine squared is positive 12. Add the 12, same thing. Good. Now what? Divide by that 16. Yeah, and you should reduce it. Good observation. So cosine. So reduce that. Divide by what? 4? Top and bottom be 3/4. We good to there so far? So that's all step 1. Get the squared thing alone. It's alone. And now, bring it down here. What do we do now in step 2? You just root it. Because that's what gets rid of squares, huh? And now you put a root on both sides, but you've got to remember, really important, plus or minus. Have you seen that before from algebra? Just think about a normal equation. What if you just had like x squared is 9? What are the real answers? What before I do any fancy math techniques, just look with me at x squared. I want to make sure this sinks deep so you really remember it. X squared equals 9. What could you put in there and make that true? What squared is 9? 3 or negative 3, right? Wouldn't you agree? 3 or negative 3 squared is also 9, like 3 squared, right? They're both answers, aren't they? If you said the answer's only 3, you'd be wrong. You'd be missing half the story. So do you see how if I only put a root and I don't put plus or minus, I would just get the 3 and I would be half wrong? So that's why when you put a root on both sides, you got to go plus or minus. Have I said that before? Oh, no. All right, so I make up dorky sayings. This is one of my dorkiest. So if you put a roof on the house, you got to go up and down the ladder. Sorry, it's kind of lame. But anyway, so do you even get what I'm saying? If you put a root on both sides. So years and years, students miss this forever. So I sat around and thought up some saying, and ever since I said it, more people got it right. So when you put a roof on, if I was going to put a new roof on this isn't my house, but if I was going to put a new roof on my house, I'd have to get the ladder out of the garage, right? I can't just jump on the roof, right? So if you're going to put a root on the house, you put a roof on both sides, you got to go and you think, what's the ladder? What are you talking about ladder? Well, it's the plus and the minus, the best I can do. Up and down, plus and minus, up and down the ladder. All right, so it's kind of lame, but maybe it's helped. So if you ever put a root on both sides, you've got to do plus or minus. You've got to go up and down the ladder. All right, so now what happens from there? So this cancels. That's why we did it, right? Because we wanted to make it just normal cosine, right? And that does it. That's perfect. Now, what about the other side? Do you remember? We'll leave the plus or minus for a minute. How do you square root a fraction? Do you know you just go to the top and you just go to the bottom? You just do them both because it's...
Root 3 over 2?
Yeah. Yeah. So that's, everybody see what's happening? It's looking familiar. There it is. We know about that guy, right? That's the large value we're used to finding. We can go to the unit circle and find him. Well, there's two of them, though. There's a plus and a minus. We got to go get them both. So everybody tracking with me? See what's happening here? So this means that we have cosine is plus root 3 over 2, and cosine is minus root. We have two, so just go ahead and separate them. Well, you don't have to, but if that makes it more clear in your mind, we're actually looking for both. So I'm going to go to the unit circle now, and I'm going to get 2 answers from this guy and 2 answers from that guy. We're going to get 4 answers altogether, right? Because every answer gives us 2 spots in the unit circle, except for the rare case when you get 1. So let's go do that. Where is my unit circle? There it is. All right. So where is cosine either plus or minus root 3 over 2? Cosine sine, there's 1. Cosine sine, cosine sine, cosine sine, cosine sine, cosine sine, cosine. There's a negative 1. Great. Got 2 of them so far. Cosine sine. There's another one. 7 pi over 6. Cosine sine, cosine sine. Cosine sine, cosine sine, cosine sine. There's another one. 11 pi over 6. See the 4 of them? 1, 2, 3, 4. 4 spots where cosine is either plus or minus root 3 over 2. So let's go back. And what is that? It's 1, 5, 7, and 11. 1, 5, 7, and 11. So 1, 5, 7, and 11, and they're all pi over 6, aren't they? Weren't they all pi over 6?
Yeah.
There they are. We're done. The 4 answers. How are we doing? Questions I can answer on that one? A couple lessons we learned there. When you have x squared or cosine squared and no regular cosine, no cosine to the first, it's easier. Just get it alone, root both sides, but don't forget the plus or minus. And then go find those values. When you got a root on a fraction, you got to root top and bottom. The root stayed on the top because you can't root 3, but on the bottom the root vanished because it rooted. When it does its job, it just leaves, right? Root 4 is 2 and it's gone. Good? There we go. Yeah, so try that one. Same kind of thing. You got a squared item, right? And there's no secant to the first power, right? There's only secant squared, so same game plan, right? Get the secant squared alone, put the roof on the house, up and down the ladder. Okay, so I'm going to jump the 10 over, so same game plan as last time. 5 secant squared is 10. Now what? Divide by that 5. So we get secant squared is 2, huh? And now what do I do? Roof on the house, up and down the ladder. Rooting cancels squaring. So what do we get? Secant equals plus or minus root 2. Everybody good to there? Now, I want to go to the unit circle, but not with secant. What do we have on the unit circle? Sines and cosines. Right? As I go around, I just write cosine, sine, cosine, sine, cosine. That's all we have is cosines and sines. So you want to change this into sines or cosines first, and then go to the unit circle. So can you change secant to either a sine or a cosine? Do you remember what he is? Yeah, he's 1 over cosine, isn't he? First off, is that okay? I'll just do that. Secant is 1 over cosine. So now again, I don't want 1 over cosine. I want just like normal cosine. So what do? Just flip both sides, huh? Since you flip the left, flip the right. So what's it going to be? 1 over root 2. But also, we don't want to leave a root in the bottom, so we have one more step before we go to the unit circle. Right, so everybody tracking with me so far, though. So I got to secant, just normal square root stuff. Then I don't want secant. I realize that's 1 over cosine. And then I just flip both sides. And then you can't leave a root in the bottom? Yeah, so exactly. We multiply top and bottom by root 2. And we get cosine of x, left out the x there, plus or minus root 2 over plane 2. That's one we've seen before. So now go to the unit circle and find that thing. Find there's going to be 4 values again, right? Because there's plus or minus options. So go to the unit circle, find it. I think what you'll find is what? Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. See if you find that on the unit circle. I'll show you. So where is, what was it? Cosine plus or minus root 2 over 2. So cosine, sine, cosine, there it is. Pi over 4. Right over here, cosine, sine, there it is. 3 pi over 4. 5 pi over 4, cosine, see there. 7 pi over 4, cosine, sine, there it is. Those 4 spots. But it's the 4 halfway points, isn't it? Because we know that's the medium, right? Root 2 over 2 is the medium. Remember, small, medium, large. 1, 2, 3. So it's the 2, root 2 over 2. So it's the medium, so it's the 4 medium spots, right? Right in the middle, right in the middle, right in the middle, right in the middle. No surprise. There we go. That's good? It's making good sense? Questions? All right, so here's where you want to start really thinking about getting the idea. So it's already got 0. It's already got 0, and it's factored. Remember the steps I've written, like with x squared, and all right, when you have x squared with an equal sign, step 1 is to get a 0. Well, notice it's already got a 0. And step 2 is to factor with the parentheses. Notice it's already done, huh? Do you see that they're giving us one that's already like step 2 done? Because it's factored with parentheses equal to 0. So that's what you got to recognize. Like, oh, they've already like done the first 2 steps. It's factored, it's equal to 0. So all I've got to do is step 3. And what's step 3? Each one gets their own 0 and solve. So this one's actually not bad. But if you don't recognize you're already in step 2, you could end up doing, like you might be tempted to say, well, I'm just going to multiply it out, I guess. No, don't do that. That'd wreck it. That'd be going backwards, you know. It's already in step 2 for you. So that's what you need to recognize. So as soon as you see that, you go, oh, okay. So it's 2 things timesing to equal 0. So remember what that means. If 2 things are timesing to equal 0, then the first one could be 0 or the second one could be 0. Either way, they'll times and be 0, won't they? So we just dive into step 3. This one's like ready to go. So can you go step 3 forward? So 2 cosine x minus root 3 is 0. Or 2 sine x minus 1 equals 0. And then can you just solve both those? Make sense what I'm doing there? We're just diving into step 3. And just solve both of those. Give you a sec. How we doing? Just working out for you? So take this root 3 and jump it over there. This will become 2 cosine is root 3, and then divide by the 2, huh? So cosine is root 3 over 2. So then we go to the unit circle looking for where cosine is root 3 over 2. So I'm going to do that. So cosine sine, there's one already. And the other one is right here, cosine. So it's a pi over 6 and 11 pi over 6. Cosine is root 3 over 2, positive root 3 over 2. It's pi over 6 and 11 pi over 6. Is that good to there? Now the other side, jump the 1 over. 2 sine x is 1, divide by 2. Where's the sine a half? Let's go to the unit circle and find where sine, 2 spots where sine is a half. So that's the same spot. But not this one though. This one is where cosine sine's half. So one of them's an overlapper, but the other one's 5 pi over 6. So we say, okay, it's pi over 6 again, and then 5 pi over 6, right? Pi over 6 again, and 5 pi over 6. So what's our final answer to the question? You don't list it twice. You just, it's just going to be 3 answers, isn't it? Pi over 6, any order you want. 11 pi over 6, 5 pi over 6. There's the 3 answers.
And it's not going to ask for the cosine and sine answers separately?
No, because we're answering one whole equation is what we're answering. Those are the answers that will make the whole equation true. Is that good? Yeah, why do those answers make the equation true? Because if you plug in pi over 6 or 11 pi over 6 to this guy, it'll make this whole piece 0. And 0 times anything will be 0. It'll make the equation true thereby. Does that make sense? And if you plug this guy in to the sine, it'll make this part 0, and anything times 0 will be 0. See how all those points will make the whole equation true? Because they'll make one or the other side 0, and then they'll times to be 0. Is that making sense? Do you see why those are true? Those are actually true values. You good with that? All right, no questions? Good. All right, so what are we going to do about that? So this one's a little different. If you think about the process we've been generally following, we try a lot, not always, but a lot of times to get a 0, which it's already got that, no, not needed. And the second step is usually what? Factor, huh? Factor with parentheses, Well, that's what we want to do here. Can you look at these two terms, but it's a different kind of factoring. It's a little bit different kind of factoring. Do you know how you could factor that left side on this one? Do you have anything in common? Yeah.
Take out a common x.
Exactly. Good job. Remember common factoring from your algebra days when two terms have something the same, a common piece? See how they both have cosine? So this is going to be like take out the GCF, the greatest common factor, take out what's in common, do just one parenthesis. It's not 2 parenthesis factoring. It's not that harder 2 parenthesis factoring. It's actually easier factoring. Just take out what they both have in common. And then how do you know what goes here and what goes there? They're going to have a minus between them. Well, factoring is just unmultiplying is what it really is. So in other words, you're trying to find out what would multiply to make this work. What would multiply to make this actually... So cosine times what would go back to cosine? Well, just 1. Huh. And cosine times what would go back to 2 sine cosine? 2 sine. Correct. Does everybody see that? Everybody tracking with me there? Yeah.
So you're pretty much just taking out the positive cosine and multiplying that to make...
Yeah, so I'm just taking out this cosine piece and this cosine piece.
Oh.
Yeah, nothing fancy about signs, just, positive or negative, just cosine. Okay. Just taking out that. See, they both have that piece, huh? They both have that piece. So it's just like if you factored x squared minus 2xy equals 0. How about that? What do these guys both have? Or no, I'm not doing a very good example. That x minus 2xy. There we go. That's just like ours. So what do they both have? They both have an x. You take it out, and then x times what would go back to x? 1, and x times what? Minus 2y. Because they both have an x. That's what I just did, huh? They both have a cosine. So if it's cosine times 1 and cosine times minus 2 sine, okay? So that's what we do. So it's which really is just like a lot of what we've been doing, when you take out what's in common. Okay, so now what do we do from here? What do we know? What is step 3 normally? So step 1, get a 0. Step 2, factor. Step 3? Each one gets their own 0. Because again, if two things times to be 0, either one could be 0, huh? So yeah, so that means the cosine alone, he's one of the pieces alone. So cosine alone is 0. And 1 minus 2 sine is 0. Or, actually, I used to stick an or in the middle. Right, does that make sense? Same logic, right? If two things are timesing to be 0, either one could be 0 to make them times and be 0, right? It's just cosine alone is one of the two pieces. And then then you solve, right? Each one gets their own 0, and we solve. So let's solve this one. Cosine, this one's done. We're ready to go to the unit circle. So let's go to the unit circle and find out where cosine is 0. So I'll crank up the unit circle again. So where is cosine 0? Cosine sine, cosine sine, cosine sine, cosine sine. There it is. Pi over 2. That's one of those only one place answers, huh? No, I'm wrong. Down here. Better be a little more careful. There we go. 2 places. Pi over 2 and 3 pi over 2 both have cosine 0, don't they? Because that means x coordinate 0, right? Both those dots have right? This dot is over 0 up 1. And this dot is over 0 down 1. So yeah, those are the 2 spots. So that'd be pi over 2 and 3 pi over 2. That's that side. Let's solve the other side now. So how do we solve? Can you do the other? Let me let you do it rather than me just whip it out real quick. Jump in now. Grab that 1. Jump it to the other side. Minus 2 sine is minus 1. We get to there. So sine is 2 negatives. Positive half. Everybody okay with those steps? I just got the sine alone. Right? The positive 1 jumped over, become a negative 1. Divide by negative 2. 2 negatives make positive. So now we go to the unit circle. Find out where sine is a half.
So pi over 6, 5 pi over 6?
Yeah, sine's a half right there. Whoops, what unit circle am I on? Oh, yeah, right there at a half. And yeah, right there, 5 pi over 6 sine, cosine sine. That's right. So pi over 6 and 5 pi over 6, those 2 places, sine is a half. So that would be pi over 6 and 5 pi. So all 4 of these are our answers with commas between them. Any order. Does that make sense there? How we doing? This good? All right. They give us a nice hint there. They say use an identity. Use an identity. So use an identity. Like one of those, identities. One of those little formula things. Yeah. So, why? Why do we got to use an identity? Well, the problem, so you know what we normally need to do. What are the normal steps? Step 1, get a 0. Already got that. Step 2, factor. I'd like to factor. But the problem is, how in the world am I going to factor that when they've got like a mix of cosine and sine? Am I making any sense? Now, of course, if I was you, I'd be thinking, what do you mean, Mr. Aaron? We just did that. Right? This is right there. There was cosine and sine. What's the problem? Yeah, but that was different. Do you see how that was different? First off, we didn't have 3 terms. See how that's just 2 terms, and they both had a cosine. So yeah, it's okay if they both have one and you can take it out like that. But see, we don't have that here. See, first off, we got a 1. He's got nothing. He doesn't have. So we can't say they all have cosine or they all have sine. They don't. So I'm not going to be able to take out anything in common. And not only that, I'm going to need to do the double parenthesis factoring, not just the 1 parenthesis. Why? Because there's nothing in common, and we have 3 terms here, not 2. Are you tracking with all that? Right? That's 3 terms. Have you noticed? Let's look back for a second. See, right here we had 2 terms. Terms are things separated by pluses and minuses. Maybe I should say that clearly. Terms are things separated by pluses and minuses. So this had 1 term, 2 terms, and they both had a cosine, so we just took it out. Right? So if you have 2 terms, you just take out the common part. But back here, look, we had, well, that was already factored. Well, that was different too. It's been a while. It's been a while since we had 3 terms. There. Well, that was the example. Yeah, it was first problem of the day. This one had 3 terms. When they have 3 terms, you end up doing the 2 big parentheses factoring. You see that? So that's where we're at. There's a fast forward to the whole lecture. All right. So, so we're going to have to do 2 parentheses, but not right now. Right now we have cosine and sine mixed. We can't have that. How's that going to work? We got to use an identity to get it all in terms of sine or all in terms of cosine. We don't want to mix. How do we do that? Well, the identity is, where should I put it? The identity is, do you remember it's sine squared plus cosine squared is 1? Remember that? That's like probably the most important identity in the whole course. The sine squared plus cosine squared is 1. So what? Well, that means I could solve for cosine squared and plug it in right there. We're going to do substitution. So how do I solve for cosine squared? What do I do to get cosine squared alone? Yeah, minus or jump it. 1 minus sine squared. Good so far. So that means anywhere I see cosine squared, I'm allowed to replace it with 1 minus sine squared. Because it's equal to 1 minus sine squared. So that's what I do. I grab 1 minus sine squared. That's an S. Sorry, my S's look like 5s. And I put it in right there. And then the whole thing will be sine. So here we go. So this will be 2. And then instead of cosine squared, it'll be 1 minus sine squared. Or I should write the whole sign there. Sine x, okay. Plus sine x minus 1. See how this part just comes down, this part they just all come down. The 2 comes down. But right where we had cosine squared, I've replaced it with 1 minus sine squared. Everybody seeing all that? How we doing? This is the kind of thing the teacher would start doing the Charlie Brown teacher voice for me. And the wah, 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 like, what's going on? I'd think, oh man, I'm just going to write this down. Think about it later. But as much time as we have, let's try to think it out together. So does everybody see I'm just simply doing substitution? I'm just saying, look, I can't have a mix of trig functions. I can't have sine and cosine. So I've got to use the identity, sine squared plus cosine squared is 1, get cosine squared alone, and substitute in for cosine squared 1 minus sine squared. Now it's all sine. Notice. It's all sine. Now it's still a lot of work to go, but at least we're in all 1 trig function now, not 2. It's all 1 trig function. So here we go. Distribute the 2. That'll be 2 minus 2 sine squared plus sine minus 1 is 0. Good to there so far. I just distributed, right? And now 2 and minus 1. What is 2 minus 1? That's just 1. Good so far. And really, we should probably put it in order. Let's put that one at the back. Everybody see what we did there? The 2 minus 1 made positive 1 at the back. Everybody see that? Okay, now we're getting close. It's hard, it's difficult to have a negative in the front. I mean, it's possible, but it's pretty hard. So it's best to get rid of that negative in the front. Let me write a note. Don't keep negative in the front. So what do I mean, don't keep negative? What do you do about it? What will get rid of that negative in the front? Multiply the whole thing by -1, exactly. Multiply by negative. You got to do left and right, huh? You got to do equal treatment, all the terms, both sides. So multiply all the terms, -1, -1, -1, -1, all the way through. So that will be 2 sine squared x minus sine x minus 1 equals 0. And now we factor. So all of that, and now we're like where problem number 2, the very first problem we did today, begins. Now we have all the factoring work to do, then all the unit circle work to do. We did all of that to get it all sine instead of a mix of sine and cosine. Tracking with me? These aren't called harder for nothing, right? All right, so now let's go to a fresh screen and do the rest of the work. So 2 sine squared minus sine minus 1. Okay, so now, everybody good with all that work? So now factor. Let me let you do the next. So now do the 2 parentheses. Good chance for you to try your hand at the factoring, the guessing, the FOIL out. Just keep trying it until you can get it to work. All right, so factor. In fact, you want to do like the 2 parentheses. And then just take a guess. You know, so don't just stare at it. Nothing good will happen. Just take a guess, FOIL it out, see what happens. If it's not working, change it. Keep going. You'll learn. You'll learn a ton as you guess and you check. That's how. And pretty soon, you do enough of these, you'll be able to just see them in your head, and you can just write them down. Bless you. Just takes practice. There's no secret. There's no secret sauce. There's no secret shortcut. You just got to do a million FOILs until you can see them in your sleep. So 2 sine and sine. We good? 2 sine, sine. It's got to be that first off, right? 2 sine times sine is 2 sine squared.
They have to have 1 plus and 1 has to be.
Yeah, and they both have to have a 1 in the back, huh? Yeah. And yeah, so then I always do plus at first. You're right, though, it's got to be 1. So then just try it out. So then we'll get 2 sine, so I'd also write an S, 2 sine squared plus 2 sine, right? That guy would go to both. Good so far? See what I'm doing? I'm taking the 2 sine to the sine and the 1. Right, 2 sine times sine would be 2 sine squared. 2 sine times 1 would be 2 sine. And then boom and a boom. Like that. We good there? So is that right then? Not quite, because that would make 3s in the middle. I need negative sign in the middle. It's always the middle that's the problem. How do you make that minus sign in the middle?
Make one of them negative.
Yeah, in fact, I got to make this one in particular negative, don't I? So minus 2 plus 1 will be minus sign. Got to make that. Now, how do you make that guy negative? It's the second one. Yeah, do you see? Just practice, because that's what will do that. It's like that. So you just tinker with it till it's right. It's just practice. It's nothing but time, and you guys got nothing but time in your schedule, right?
Oh, yeah.
I know. College is killer that way, especially if you have to work while you're doing it. All right, so let's keep going. So now, got two things multiplied. You know what to do here now, right? Two things are times to be 0. So the first one is 0, or the second one is 0. And then move it over. 2 sine is -1 over 2. Boom. This one, sine is 1. We go to the unit circle. Where is sine -1/2? So I think what you'll find, what is it? Isn't it 2 pi over 3? And whatever that is down there. 1, 2, 3, 4, 5, 6, 7, 8 pi over 6, 4 pi over 3, right? Isn't it those two? No? Am I getting it wrong? Oh, no, that was not right. Oh, I'm doing cosine. I'm totally off. I'm doing cosine. Yeah. Wait, don't tell me. Don't tell me, Kevin. Hold on. Let me think. Where is sine -1/2? So it's going to be 11 pi over 6 is the second one. The other one is 1, 2, 3, 4, 5, 6, 7 pi over 6. There. I think I got it now, right? 7 pi over 6 and 11 pi over 6. And then where's sine 1? That one's easy. Pi over 2. Alone. No second answer. Yeah, that one's just a one answer.
So that's the exception we were talking about?
Yeah, that's one of the few exceptions. All right, then okay? I just went to the unit circle in my head because I've done it 10 million times. And say boom, boom, right? We just said where's the sine -1/2? It is right cosine sine right there. And right there, cosine sine. So we got those two spots. And then where's the sine 1? Cosine sine right there. Pi over 2. So there's our answers. Are we good with that one? Does that make sense? That was a long problem, wasn't it? So from the beginning, one more time, from the beginning, you have to get them all sine. So we had to use an identity. Cosine squared is 1 minus sine squared. Plugged it in, kind of cleaned it up, got it all sine. Then we factored and each one equal to 0 and solved. Questions? Is that good?
Same one on, never mind.
Same. Want to try that one? It's the same kind of thing. You can't have a sine cosine mix, right? So you got to replace that sine squared, don't you? So use the same identity. Basically, it's going to be 1 minus cosine squared. You getting the hang of that? It's always, sine squared, cosine squared, they're always 1 minus the other guy. Because it comes from the basic relationship, sine squared plus cosine squared 1. So we want to replace this guy this time, don't we? We're always replacing the squared piece. Maybe I should, say that clear. We're always replacing the squared piece. So the regular cosine is going to stay. In fact, the whole thing's going to become cosine. Get the idea? So sine squared, jump this over. Sine squared is 1 minus cosine squared, isn't it? So right here, I'm going to put 1 minus cosine squared. Isn't that good? And then all the rest, and then clean it up, and then factor it, and then each one equals 0, and solve those, and go to the unit circle. Trig equations. Like that. Keep going. So remember, you don't want negative in the front, so you're going to multiply through by -1, huh? Right? It's just easier to not have negative in the front. So you combine the 1 and the 1 and the 4 make 5, don't they? So they make 5. The 1 and the 4 make 5. And then we don't want to have a negative in the front. So we multiply through by -1. Just easier to have positive in the front. It's easier to factor. It's just for our convenience. There's no real math reason you have to. It just makes it easier for us. So now can you factor? See if you can do the 2 parentheses and just keep tinkering with it till it's working. Factor that thing. So cosine's in the front, right? Cosine times cosine, cosine squared. What goes in the back? What times what's 5? Well, remember, it has to multiply to be 5. It's got to be 5 and 1. It's got to multiply. Remember, when you FOIL, the back number's times. So that just takes practice. You just got to do more and more and more of these, and you'll get the hang of them. So 1 and 5, because it's got to multiply. So I would just stick in plus signs right now and just try it. I would just multiply it and see what happens. Just FOIL it out. So don't try to get around that shortcut. Don't try to just look at it, and that's what I've seen students do. They'll try to just look at it and sort of randomly hope, and I'm like, what are you doing? FOIL it. Why guess? No. Actualize that hope. Do it and see if it's right or it's wrong. Don't hope without reasons. How about that? Use wise hope to just give it a try. See if it's right. So cosine squared plus 5 cosine. And then the 1 goes to both. 1 cosine plus 5, right? What did that take me? 5 seconds? I mean, it might take you longer, but the more you do it. It's like tying your shoe when you're a kid, right? It took forever when you first learned, and then you can whip it. You'll get quicker and quicker and quicker the more you do. All right, so is it working? Is it right? I got to get 4 in the middle. How can I adjust it now to get 4 cosine in the middle?
-1.
Got to make that a -1. So that's not bad. Just come up here and make that a -1. Oh, and that'll also make this a -5, won't it? Which is actually what we want. That's perfect. There it is. Do you see that? You see how that FOIL is correct now? If you're not sure, try it again. Cosine goes to both. Cosine squared plus 5 cosine. And then the -1 goes to both. Minus cosine minus 5. And that'll make 5 minus 1, 4 in the middle. Perfect. See that? So just FOIL it out and tinker with it until it's right. And now set each one equal to 0 and solve. What are you going to do with that cosine equals -5 one? What's the highest sine and cosine ever get? Yeah, and lowest that gets -1. Throw away that -5. There's no answers out of that side. So cosine -1 is 0, or cosine plus 5 is 0. We get to there. Move that 1 over. Cosine is 1. Go to the unit circle. Where is cosine 1? Cosine is 1. Yeah, right there. Cosine 1. So it's 0. And that's it. That's one of the 1 answers only. So that's it. Just x is 0. And now what about the other one? You move it over. Cosine is -5. No. Cosine's never -5. First off, -5. Now, how would you know that? Well, cosine is not, -5 is not in my unit circle. If you did cosine inverse in your calculator, it'd tell you error. No. And you know that cosine, he's the one that starts high and goes low. The highest he ever gets is 1. Lowest is -1. He's never -5. It's not going to happen. So the only answer is 0. All that work for 0.
Doesn't that be radians?
Okay, now it's radians. It's 0.
Okay.
So 0 radians is 0 degrees. It's 0.
Okay.
Yeah, it's a nice thing about 0.
Would it accept 2 pi as an answer?
Good question. No is the answer, because look at that. They said 0, 2 pi, but not touching 2 pi.
Okay.
Yeah, because that's why they did, because they don't want the double answers. Because otherwise you'd be like both are true, which they are, but they don't include 2 pi in the region. That's why remember parentheses mean not including, so they don't want 2 pi.
So the answer is 0.
The answer is just 0 after all that work. Answer 0. You good there?
I have a question.
Yeah.
When we have the cosine x minus 1 and then we put over.
What's that?
I did it wrong.
You good? You seen it,
Yeah.
Miriam?
Yes.
Anything else on that one? All right, we still. So what's the issue with this one? Something is weird about this one. I know it's hard to tell if this is all just brand new to you, which I know it is for all of you. But what's especially weird about this one, which we never let remain for long, we always handle right away, is the fact that this is 2x and this is regular x. You can't have those being different. They can either both be 2x or both be regular x, but we can't have like different angle amounts in there. We can't do that. There's just no way to deal with that. So we got to do something about that. So when they say use an identity, you should really be thinking about that guy. Thinking, Now, this test that we take, our windows are next Wednesday. Next Wednesday's our exam. This is the last of the material. We're going to do the practice exam in class Monday. This is it. This is the end of the chapter 3 here. And so practice exam on Monday, real exam on Wednesday. So sine 2x, you'll have it on your 3x5 card. It was from, the last section we covered last week. It's 2 sine cosine. So sine of remember the double angle, half angle section? You'll have that on your 3x5 card from the double angle, half angle section. So you'll have sine of a double angle is 2 times the sine of the regular angle times the cosine of the regular angle. So we'll take that right there and plug it in right there. So we'll get 2 sine regular x cosine regular x. Like that. Now, why do we do that? Because we want everybody regular x. We don't want anybody 2x. All right. Can you take it from here? So now we go to the normal steps. Now, what do I mean the normal steps? What do we normally do? Step 1 normally? Get a 0. Yeah. Now, I say normally because it's really not always. There are different things we do different, but it's typically, usually, more often than not. Get a 0, factor, each one equals 0, and solve, right? Go to the usual steps now, and it should work for you. So step 1, get a 0. What do I mean by get a 0? Just grab this whole term and jump it to the other side. It's negative on that side, so when it comes over, it'll be positive, right? So we'll have 2 sine cosine plus root 3 cosine. You good? Good to there. So we get a 0. That's step 1. Get a 0. Step 2, factor. You know how to factor that thing, right? They have something in common, don't they? That's going to be the 1 parenthesis, not the 2. 1 parenthesis. Take out what's in common. Put the GCF in the front, which is cosine, right? They both have cosine. So take out the cosine, put it in the front. take out cosine. That leaves 2 sine plus root 3. We good to there? Fine, because if you multiplied that, it would go back, huh? We good? So that's step 2, factor. Step 3, you know what to do, right? Each one gets their own 0, which is, one of them is cosine alone. Cosine alone gets a 0, and then the parenthesis gets a 0. And then get those alone and go to the unit circle. So cosine alone is 0. 2 sine is 0. Like that. And so I'll go to the unit circle, find where cosine is 0. Where is cosine 0? So cosine is 0. Cosine sine, so it's up here, huh? Cosine sine pi over 2 and cosine sine 3 pi over 2. So this side is pi over 2, 3 pi over 2. The other side, we got to move the root 3 over. Divide by the 2. Like that. So then we go say, where's sine? Negative root 3 over 2. I think it's here, cosine sine. And here, cosine sine. So 4 pi over 3, 5 pi over 3. So 4 pi over 3, 4 pi over 3, 5 pi over 3. So there we go, our 4 answers. Are we good? Like you guys can do these? There's one more level we're going to go to. We good with that? You're doing well, though, if you can get to here. Identity, okay. Well, basically, you'll have your 3x5 card. It's this guy. You'll have on there, when you take the test next Wednesday, you'll have on your 3x5 card, cosine of 2x is cosine squared minus sine squared. You'll have that one right on your 3x5 card. So that means you'll take this and you'll go right there for that. So that'll become cosine squared minus sine squared. So that's the double angle formula for cosine. A minute ago we did the double angle formula for sine. You'll have all those double angle and half angle formulas right on your 3x5 card, right? So you'll just see it and you go, oh yeah, double angle, grab it, boom, pop it in. So that won't be too bad. But now what? Let me give you a second. We got to make this thing all cosine because he's not going anywhere. We're not replacing, we only replace squared pieces. That special replacement is squared pieces. So we're going to make this thing all cosine. So if I'm going to make it all cosine, then which piece do I need to replace? Get out of there. I got to get this guy out of there. Don't I? I don't want sine squared then. I'm going to get it all cosine squared. Tracking with me? Going to get it all cosine, I mean. So, okay, so let's do that. What's that going to become then? It's cosine squared minus, and right there is going to be my replacement. And let me write everything else down first. Okay. So sine squared is going to be replaced with what? 1 minus cosine squared. Exactly. Getting the hang of this? You can always replace sine squared with 1 minus cosine squared or vice versa. So sine squared is 1 minus cosine. So this is a hard one. We're using two identities. Two identities. Now you got to take that minus and distribute it, huh? Distribute that minus. gather like terms, then it should work. You know, factor, and oh, and this is going to be a harder factoring one. It's a hard problem. Yeah, I better dive in. I wish I had time to let you work on it more and you'd get more out of it, but that clock's a-running. So distribute that minus. So we get cosine squared minus 1 plus cosine squared. Everybody see what happened there? A minus distributed. Cosine squared plus cosine squared? Good. 2 cosine squared minus 9 cosine. Minus 1 and plus 5? Plus 4. Good to there? Everybody see what I'm doing? So this one's not at all easy. So we started with the double angle for cosine 2x, and then we had to get rid of the sine squared, 1 minus cosine squared. Distribute, gather like terms. Now what do? Got a factor, huh? Can you factor that thing? So try, just guess, and then try it. The learning will come quick as you guess and try, guess and try, guess and try. I'm going to go to a fresh screen. Everybody got that part down okay? So 2 cosine squared. What is it? Minus 9 cosine. Plus 4. Okay, so 2 parentheses. And so we have 2 cosine. Cosine, so that'll make 2 cosine squared, right? Are we good there? 2 cosine times cosine is 2 cosine squared. And then back times back. So last times last to make 4. What times what makes 4? 2 and 2 are 1 and 4. Yeah, let me give you a tip. You'll never have two numbers in the same parenthesis that have anything in common. So I could not put the 4 here. Why? Because they both, because that 2 could come out. You see, they both have a 2 in common. So why is that the end of the world? So what? A 2 can come out. Well, a 2 can't come out. If it could, there would have been a 2 in common to everything in the beginning, and there wasn't. There was a 9 here. They don't all have 2 in common from the beginning. So how could they have 2 in common later? They can't. So it'll never be the case that you have 2 things in common later like that. Can't happen. Not only that, I can't put 2 and 2, because then they'd also have 2 in common. So that kind of narrows down your possibilities right away. It's got to be a 1 here and a 4 there. Helps speed through some of the options. It's got to be like that. Now, what signs do we need?
Both negative.
Yeah, both negative, because they're going to multiply to be positive 4. Now, that's really right. If you check it, remember, it's always about checking. If you check it, boom, boom, you'll get 2 cosine squared minus 2 cosine times 4, 8 cosine, boom, boom, minus cosine plus 4. So that's right. Minus 8 minus 1 is minus 9 cosines. Perfect, huh? So that's the right factorization. So I'm always checking them. Do that enough, pretty soon you'll be able to do that in your head. So now you know what to do from here, right? Each one gets their own 0. So you know the drill from here. It's the typical. So 2 cosine minus 1 is 0. Cosine minus 4 is 0. Jump it over, jump it over. 2 cosine is 1. Divide by 2. Cosine is 4. No way. I was going to say no. Cosine can't be 4. Where's cosine half? Go to the unit circle. Cosine's half at, isn't it, pi over 3 and 2 pi over 3? Oh, that was wrong. Yeah. What is it? 1, 2, 3, 4, 6, 7, 9, 10. Yeah, 5. Thank you. Pi over 3. 5 pi over 3. There we go. We good? questions on that one? Okay, they probably say use an identity. Yeah, use an identity. Okay. Yeah. Yeah. It's just a hard one. All right. So it's not a super easy way to explain it. It's just a little bit of trickery. So first off, the problem with it is if this was just 0 on the right side, then it wouldn't be a problem because then you'd have two things multiplied to be 0. But anyway, let me just jump to it. Here's the trick. Have you seen this before, like a sine and a cosine next to each other in an identity? Actually, even today. Let me go back and show you. There it is. See the sine and the cosine? Now, it's got a 2 also. But see it there? That's the one we want to use, except we've got to divide by the 2 on both sides. We've got to alter the identity to use it. So that's the one they mean. So let me write it. It's the double angle. Sine of 2x is 2 sine cosine. Yeah, a little more room here. So the double angle sine of 2x is 2 sine cosine. That's the one I'm going to use. But I don't have a 2 in the front, right? There's no 2 over there. Right, there's not. So you've got to get rid of this 2. You've got to tinker with the identity first. Make it look like what you want to replace. So this will be a half sine 2x. Everybody see what I just did there? I just took the identity, the double angle identity, sine 2x is 2 sine cosine, divided by 2. Why? Why? Because I need to replace this. I need to get something that looks just like that so I can stick something in its place. Does that make sense? And so to do that, I divided by 2. Now this looks just like that, doesn't it? Austin?
Become 1/2.
Right. Dividing by 2 is the same as a half, right? Dividing by 2 is the same as multiplying by half. So that's just easier, I think, to do it that way. Well, you don't have to. Whatever. If that bugs you, just leave it the other way. Yeah, there's no reason. I don't need to. I thought that might be helpful, but I see now it won't be. So yeah, just leave it that way. That's totally fine. Just plug that in right there. So that's sine 2x over 2 is minus root 2 over 4. We good so far? Everybody see that? Now, why are we even doing that? Well, because that gets it down to one trig function. It's just sine now. It's not sine and cosine. It's simpler. Okay, now, how did we solve when we got 2 equal fractions? Have we done this before? Diagonal, diagonal? Yeah, just cross multiply. So you'll get 4 sine 2x is minus root 2, or is 2, well, it's minus 2 root 2. How about that? Can I just do that? Right, those guys multiply 2 times negative root 2. Is that good to there so far? 4 sine 2x is minus 2 root 2. Now, how do you get the sine alone? Divide by 4. Boom. Sine 2x equals 2 goes into 4 2 times minus root 2 over 2. There's something we recognize. Did you track with all that? It might have been easier up here on this side just to multiply both sides by 2. Yeah, I probably overdid that, guys and gals. You could have just multiplied by 2 on both sides. Cancel that out. Anyway, whatever. I hope I'm not confusing you by showing you too many ways. Cross multiply was fine. Just took an extra step. All right, we good to there? Let me go to a fresh screen if you're okay with that. So now, here's my question. Now, do we just go to the, we do. Let's go to the unit circle and find where sine is negative root 2 over 2. So let's go to the unit circle. Negative root 2 over 2. So sine, where are you? Negative root 2 over 2. Yeah, cosine, sine. There, and yeah, 5 pi over 4 cosine sine. Yeah, exactly. Sine is negative root 2 over 2 at 7 pi over 4 and 5 pi over 4. We good? Middle spots. So, okay, so I'm going to bring this back. This is sine 2x is minus root 2 over 2, right? That's my thing. Yeah. So what did I get? 7 pi over 4 and 5 pi over 4. So we say, okay, the answers are 5 pi over 4 and 7 pi over 4. But, here's the trick you might forget. This isn't x. It's 2x. It's 2x. It's not x, right? All the other ones at the end, like, look here. See, this was just regular x. Regular x. So when we got it, we're done. It's just x. There it is. There's x. Boom. Done. But this time, it's 2x. So that means we have more work to do. Is everybody seeing that? More work to do. What more work? What do you have to do? Remember Monday? What do you got to do when you have 2x or 3x? Remember the awful thing? We got to do that awful thing. Plus 2n pi. Plus 2n pi. That's when you have to do that. It's when you've got the 2x or the 3x, you've got to do the plus 2m pi. Remember that whole thing? Painfully? And then what? Well, we got to make regular x, right? Our goal is always to solve for regular x. How do we get regular x? Divide by 2. Remember how we learned to do that? How do you divide a fraction by 2? You multiply the denominator by 2 and divide that other guy by 2. That is dividing everybody by 2, right? So x will be what? 5 pi over 8 plus, these cancel, n pi. The other side, same thing, divide by 2, multiply the denominator by 2, divide by 2. That means x equals 7 pi over 8 plus the 2's cancel, n pi. So when you have 2x or 3x, you need to do the whole 2n pi thing. Remember that? Those were the hard ones. So whenever you have 2x or 3x, you have to do that plus 2n pi. Get down to here. Now what do we have to do? Remember? N equals 0. N equals 1. And remember that whole thing? You got to do that whenever you have 2x or 3x. Right? Because there's different options. Okay, so you plug in 0. That one's easy, just 5 pi over 8. But you plug in 1, you get 5 pi over 8 plus 1 pi. So now you got to do common denominator with those. Right, 5 pi over 8 plus 8 pi. You just put this over 1. Multiply top and bottom by 8. 13 pi over 8. So we've got those two answers. Now we got to get the 2 from the other side. N equals 0. That'll just be 7 pi over 8 because the n is 0. N equals 1. Going to get 7 pi over 8 plus 1 pi. Put that over 1. Multiply top and bottom by 8. 7 pi over 8 plus 8 pi over 8. 15 pi over 8. There's our 4 answers. And I got the big bad number 12 and 13 still to go. Are we good? Does that make sense? So when do you have to do that whole n thing? Whenever you have 2x or 3x. When you have a 2x or 3x, you've got to do that whole extra thing. Remember, how far do you need to go? You always have to go 1 shy of the number. So if you did 3x, you have to do 0, 1, and 2. Right? If they give me 5x, I have to do 0, 1, 2, 3, and 4. Remember that? Remember that from last time? If you haven't got that down, I'm glad to help. Come see me or Wendy. All right. Now, it might look kind of nice. Like, hey, it's just a simple sign. It's nice. It's not like sine squared and cosine and use identities. Right. That part's nice. No identities. None of that monkey business. The hard part is we got to use our calculator because that's not one of the values on our unit circle, right? There's no negative 0.5092 on the unit circle. So you might think at first, well, that's not hard. Just hit the buttons on the calculator, right? Just hit sine inverse, right? Isn't that what you would do? Sine inverse? Totally right. Negative 0.5092. That's not writing that very neatly. 5092. Let's do it. So, make sure you're in radian mode. Yeah, let me write that. Radian. They want the answer in radians. So put your calculator in, it's probably in degree mode right now. Go to the mode button, put yourself in radian mode. Come grab me after if you're a little rusty on how to change your calculator's mode. So anyway, I'm getting the answer negative 0.534. I'm going to use a little more accuracy here. 255. You getting that? Everybody able to get that in their calculator? That okay? That's the radian thing there. So if you type that in as your answer, it'll say you're completely wrong, and it'll give you two totally different answers than that. Why? This is where the tough part comes. Why is that not it? And why are there two completely different answers? How do you get two? Why are they different? What's going on here? It's all about the unit circle and what they want from us. Look what they want. They want answers between 0 and 2 pi. Positive, that means. No negative answers, please. That's what they're saying. Between 0 and 2 pi. That means positive, huh? There's no negatives between 0 and 2 pi. So they don't want, this answer is the right spot on the unit circle, but they don't want me to say it that way, and there's a second spot. Right? Like there's usually two spots. No surprise. So how do you find those, though, when you don't have a nice little unit circle to look at? Yeah, you got to think the thoughts of the unit circle. I mean, unit circle can't think, but you know what I mean. You got to think like how the unit circle works. So how does the unit circle work? So here we go. What would be a nice, I want to give you like a step 1, step 2, step 3. Now, okay. Yeah, so for 12 and 13 in the homework, calculator. And what 12 and 13 are is calculator problems. They'll both say use your calculator. And there'll be one of these on the exam in a week. So there's not going to be 10 of them or something, but there will be one of them, which means half a grade, right? Because 20 questions, every question's 5 points. 5 times 20 is 100. So half a grade next week will be your ability to do this calculator one. So how do these always work? First step, do the whatever, sine inverse, cosine inverse, whatever, get your answer. Okay? Do whatever you need to do. Then, so do the sine inverse thing, whatever. Change answer to positive. We're just going to use the positive version. Positive. Then, find the two quadrants where your sine or your cosine, whatever you're looking at, has the correct sign as in positive or negative, whatever they're wanting. So on my problem, we're wanting negative. They're saying, where is sign negative, please? Right? That's what they're asking me. See what I mean by the sign they want on the problem? They're asking me, where is sign this negative number? Right? So you find the two quadrants where that's happening. So first thing I'm going to do is I'm going to change this guy to positive. Change it to positive. Find the two quadrants where sign has the right sign, if you know what I mean. Negative. Where is sign negative? All students take calculus. Where is sign? Which two quadrants, there'll be two places, always two, is sign going to be negative? Third and fourth, right? Because all are positive here. Sign is positive in the second, third and fourth. So we're talking about third and fourth quadrants. So now, okay, so what? This right here, what this is a reference angle. What the inverse trig button does on your calculator is it gives you a reference angle. What in the world, it's been a while since we talked about reference angles. What in the world is a reference angle? An angle off of the, which axis? Which axis do we always use for everything? X. X, because it all started with 0 degrees at X, huh? Reference angles are with reference to the x-axis. They're always off the x. So you basically have to find the angles from 0 that land in the third and the fourth quadrant that are off of the x-axis. See, I'm coming off the x, not like this, not the y, right? Coming off the x in both those quadrants, that is the .53425, 0.53425. So it's got to be off of the x that amount into those two quadrants. But you've got to find it starting from 0. They want the actual angle from 0, meaning from here to there is how much. And from here all the way to there is how much. That's what they actually want. Those are the actual angles from 0. Let's track with all that. Step 4. Find reference angles in those two quadrants. How? Here's how. If you're in the third quadrant, it's always going to be pi plus your reference. If you're in the fourth quadrant, it's always going to be 2 pi minus your, I'll give you reasons for this in a second. 2 pi minus your reference. If you're in the second, we're not in the second quadrant on this one, but some other problem we may be. It's always going to be pi minus your reference. And if you're in the first quadrant, it's just your reference. There it is. You can put that in a 3x5 card if you want. Be a good idea. So just find the two quadrants you need, get your reference angle, and then plug into the formula for those two particular quadrants. I need what? Third and fourth. So I'm going to take pi plus that reference angle we just found, and 2 pi minus the reference angle we just found. So copy that down. It's going to be what we use. Boy, that clock's just moving. So let's go back and do that. So here we go. So we're in the third. I'm going to take pi plus that. And in the fourth, I'm going to take 2 pi minus that. Now, go to your calculator. Use the pi button on your calculator. You don't just use 3.14. You will get it wrong. They want it accurate to 4 decimal places. Oh, by the way, notice I used 6 places here. 6 or more you should use. Right before class, I was trying to do it quickly, and I only used 5 places, and I got the answer wrong. Remember, whenever a final answer needs to be accurate to a certain number of places, you use more than that along the way. And in fact, at least 2 more. So everybody track with all that. I know there's a lot of complexity to this one. So they want the final answer right to 4 places. So that means I use this intermediate answer 6 places. Use it 6 places, then use the pi button and add, and the pi button and subtract. So there's the 2 answers. Let me give you a reason why we do these little formulas. So everybody getting those 2 answers in the calculator? If you're having trouble, come up. I'd be glad to help you. Just take a second. So again, here's the 4 magic formulas you want to know. Why is that correct? I don't want that to be magic. Why is that right? Well, because remember, if you look at this one, for example. If you want to know what is this angle here, all the way around to here, do you see that it's all the way around would be 2 pi? Back up the reference. See why it's all the way around, back up the reference, 2 pi minus the reference? And if you're in the third quadrant, it's pi, it's halfway, plus the reference. You see? And if you're in the second, it's pi back up the reference, isn't it? Pi minus the reference. Well, 14 and 15 are not that bad. 12 and 13 are the same. 14 and